Thanks for the opportunity to speak today. So good morning, good afternoon, or evening to all of you, depending on where you are in the world. Thanks for making the time today to attend the VP Energy Summit. As Cynthia was indicating, my name is Kevin Wong, and I'm the General Manager for Emergent Energy Solutions. The next 45 minutes, I hope to provide an overview of how metering can deliver value to you or your customers and can help differentiate your sales process and help with transitioning your relationship from a transactional relationship to a true business partner, hopefully, with your customers. And of course, if you have any questions, please enter them into the Q&A box, and I will work to either address them during the presentation or at the end of the presentation, where we will have a Q&A as well. Okay. All right, so a little bit more about Emergent Energy Solutions, energy services company specializing in development and implementation of turnkey projects for our customers. We provide consultative services, includes utility rebates, which is a big thing in the US. I'm not sure how many of you guys are from the US, but the utility grid here and also the local utilities provide incentives for energy efficiency investments. And we help with submission of project applications for those funds that help offset the cost of upgrades to facilities. We also do energy audits and provide energy commodities and PJM energy credits, which is something that's specific to the Northeast Mid-Atlantic utility grid. We also provide turnkey solutions that includes LED lighting, energy metering, of course, building automation, nitrogen generation, cogen, and solar projects. If you find out more, visit our website at emergentenergy.us. And I believe a little bit about myself, General Manager for Emergent Energy. And my central role here is the development of projects and engineering and implementation. I previously worked at Kraft Foods as an energy environmental engineer and Bimbo, and also an account manager at Honeywell International. Before we get started, I have a 4-question poll that I would like to pose to each of you to gain a better understanding of the audience so that I can then focus on specific points during the presentation. Okay, I'm going to start the first one here. And the question is, are you a systems integrator, a mechanical or electrical installer of metering products, or are you an end user? So if you can just take a few seconds here to answer this. I think that about does it. So majority of the folks here are systems integrators, which this presentation should apply well, and of course mechanical, electrical installers, and then there are several end users here. So here are the results for you if you're interested in seeing. And then the next question I'm going to pose is, does your organization perceive energy metering as a core service, meaning during your sales process? Is it something that you focus on specifically as a core product, or is it an add-on accessory to compressor sales? So your primary business is selling compressors, and metering is just a nice add-on to provide to your customers. And it's leaning more towards here. I can show you the results of this. It's more or less 50-50. But I believe it's still moving up and down a little bit, but it's a pretty even split here between an add-on service and a core service as a metering solution. Okay, thanks for that feedback. All right, I'm going to start the next poll. And the question is, how does your customer view your relationship? Are you a long-term partner? Are you a transactional service provider? Or are you not sure? Okay, this is fantastic. It's the majority of you are long-term partners, providing continued solutions and also investing in that relationship with them. And of course, they're continuing to invest in your business as a service provider to them. So and then my last question is, do you believe that energy metering to be a market differentiator when you're pursuing a new opportunity? All right, so it's all yeses, which is fantastic. So I'm going to dive right in now, and we're going to use Lavazza Professional and our relationship with them as a case study. Okay, so since my presentation is based around the value of metering, we're going to share with the group the details about our relationship with Lavazza. So how do we work with them and their energy management program at their US facility? We're also going to review Lavazza's journey as they leverage data to drive decision-making as well as process management and continued energy efficiency projects. I'm certain that over the next 2 days, you'll have learned much about the various metering solutions that VP offers for your specific projects. but our presentation will speak to an enterprise-level energy management platform that uses various types of meters for different types of energy measurement. So we will then close out the presentation by discussing specific process management benefits, and of course, the value that this all translates to the customer at the end. So it's just some brief information on Lavazza's U.S. operations. The business, which includes multinational facilities, it includes the Falvia brand, which is, and also the Clicks brewer. They were all investments into the coffee space by Mars Drinks originally in the 1980s, when coffee demand was taken off in Europe and then soon after the U.S. During the single-serve coffee boom that began with the Keurig branded products from Green Mountain around 2010, the single-serve coffee market just continued to grow within the U.S. And in 2018, Lavazza purchased Mars Drinks, the entirety of all its assets, for about $650 million to move into the global office coffee service space. Prior to this, there was not really a good product from Lavazza to fit into that space. Like many global enterprises, Mars Drinks in 2015 had to focus on a cradle-to-grave approach in its supply chain process. The supply chain process has only grown in significance as the world continues to invest heavily into either carbon neutrality or just reducing energy and finding renewable sources for energy to fulfill the manufacturing processes. This required Mars at the time to make specific investments in its raw ingredient sourcing, manufacturing processes, and consumer waste management. Okay, the strong focus on sustainable manufacturing and fair trade sourcing from their raw ingredients. Mars used sustainability as a quality as a differentiator as they marketed the products to their younger, trendier customers that are based out of the U.S. cities, and I'm sure it's the same in Europe too. So from the sourcing strategy standpoint, they sourced 100% of their coffee and tea products from certified sustainable sources, and then from the manufacturing front, they focused on reducing energy and water use, zero waste to landfill, and adopted ISO 14001 environmental management standards. And they also invested in a 118 wind turbine farm in Texas and invested in the largest self-use nitrogen generation system in the Northeast at the time of the purchase. In 2015, Mars upgraded its global headquarters. Mars Drinks upgraded its global headquarters and manufacturing facility to be LEED Gold certified. This site is ranked #1 across all 140 Mars Incorporated facilities. And shortly after, the facility then invested in the energy management system that we'll speak of shortly here, that metered natural gas, electric, compressed air on both the supply and demand side of the system. The energy metering system also provides flow-based sequencing for their compressors, automatic nitrogen feed, and upgrade of over 900 horsepower of air compressors. On the consumer waste reduction end, Mars focused heavily on reducing the waste and improving recyclability of its used single-serve packaging, which is a huge problem for the single-serve coffee market because you're just mixing organics with plastics and they don't degrade well. And through this three-pronged approach, Mars focused on sustainable sourcing, manufacturing, of course, waste management. So turning our focus into the value delivery end of things and how we implemented the metering strategy at the site. So the Lavazza facility generates compressed air to generate nitrogen primarily. During the last presentation or the webinar, Amino had spoke specifically about nitrogen becoming a big, metering point. But this facility is one of those that uses a tremendous amount of nitrogen for their processes. It has actually a fairly low pneumatic actuation compressed air load, as over 90% of the compressed air capacity is used to generate nitrogen. To manage the facility's energy management needs, we apply a energy tiering structure to the metering project. So as you can see here up top, electric is metered in on the utility level coming in. So we basically measure all of the electric, gas, and water coming in. And then tier 2, we pick up all the circuits from their main incoming switchgear. There's about 30 or 40 circuits. We pick all those up so that we can then allocate where these energy is being used and segregate their infrastructure and operational uses. Then we can then allocate electric load for all their compressors, all their HVAC, all their lighting, refrigeration, and office loads. The third level metering includes metering of generated compressed air coming out of these compressors here to help manage and visualize compressor efficiency. So now we know energy coming in, we know compressed air leaving. We basically can determine the system efficiency, proper sequencing, and optimal sequencing for either running days or down days. And then from that end, we then meter all the overall nitrogen generated from all of their nitrogen generators. The site here actually has 18 nitrogen generators that put out about 500 CFM of nitrogen continuously to feed their production lines. And finally, the fifth level is the production lines, or are the production lines. Within each of their fillers, these are form, fill, and seal fillers. We meter the nitrogen, compressed air, and electric going to each production line. So through this process here, breaking it up into main incoming, kind of a compressed air nitrogen as a primary infrastructure system, and then of course the end use as the production line, we're able to get a fantastic view of where energy and air and nitrogen are all being used throughout their facility. And of course, they use all this data to track their ISO 14001 requirements on the reporting end. So nitrogen is an expensive commodity for the coffee business because, as you guys might know, it's a great antioxidant. It protects shelf life and product quality. Before its investment into its own nitrogen generation system, the site was spending roughly $500,000 per year on bulk liquid nitrogen. And if you ever look up the Parker nitrogen system brochure and you pick that up and you look into it, the photos within it are actually from the facility, and these are two of the photos. These are the different banks of nitrogen generators, the primary integration, or at least the headers that bring everything together. It's just one of the largest systems installed in the Northeast at that point in time, specifically for its own use, not for resale. Of course, the companies like Praxair, US Gases will have much larger systems because they're basically generating nitrogen and then liquefying and then transporting. So the compressed air demand from this facility is about 2,500 CFM. Of course, that translates to roughly 500 to 600 CFM of nitrogen. So the use of metering is on the nitrogen system to determine system capacity constraints, as well as generate efficiency. It also provides a pulse of how production is running based on their nitrogen flow. The facility uses nitrogen to purge its fillers. Therefore, the more nitrogen use, the more downtime they're experiencing. So the site actively manages its bulk nitrogen use through the VP meters. So one of the projects, one of the components that we implemented at the project level was that because sometimes they will run into problems with the nitrogen generation side, or they have a compressor down, there really was no assurance that they were going to keep production running. So we implemented a pressure-based control for their automatic bulk feed system. So they kept their bulk tanks, and then they used that for other benefits also. But the reliability aspect provided by liquid bulk nitrogen on site, along with self-generation, provided tremendous savings for them. This is a quick overview. This is a very simple overview of some graphics that we have at the facility. So the next few slides will basically provide overviews of how we integrate and how we kind of bring all the data together as an enterprise level. So this is a graphical view of 4 of the site's air compressors, their operational status, compressed airflow, and they're all metered at 3 different points. So we meter them at total compressed air from the compressors running, and then we also meter them coming out for either plant air or nitrogen flow. We also then are able to trend their data. Data from all our analog points coming out of the VP meters are then trended, and we have a historian that's collecting data at the 1-minute intervals, and they can see exactly what's happening within the facility at any point in time, either during down days or up days, and they can then correlate this data back to production line data. The next screen here basically shows some production data from each of their fillers. So we have the KW data, the compressed air data, and then nitrogen flow data. We do have some electrical noise issues that they have at the site. That's why some of them are negative. But in general, it provides them with a view of exactly what's happening on the electrical end, the compressed air end, and the nitrogen end. And of course, they can query each point on a historic basis and then determine their OEE, or they can then correlate this back to the supply side, see if there are any issues on either front. So just to provide a little bit higher view of one of our other customers, who basically from an enterprise level, this is an entire winery with 10 metering panels that we're integrating. roughly about 100 circuits that are being brought in to the system. This is just a simple graphical view. We're managing and tracking voltage, demand, and kWh across all these panels, and they're able to then segregate once again, and then determine their infrastructure system loads, provide data for procurement purposes, for energy procurement, and then plan for capacity planning and all that. So metering can deliver significant value to basically any site. The next view here, this is the chiller plant. It's another, kind of graphic of that shows the condensers, the compressors and pumps, the glycol pumps, and how the system's all running and pulling together, and with a historian that runs behind it. I mean, this is not fully commissioned yet. The facility will be able to track electrical loads, start-stop operations, receive system alarms through email or text message, and then manage the overall operation of the refrigeration system through the same energy management platform that does tracking of the metering data. So the system can do both control and also historian purposes. And then from a high-level tiering structure for multi-site facilities, our approach is to basically integrate the data that we have from each facility into a single master panel, and then through their customers' network infrastructure, feed up to a cloud-based AWS server, or feed to a different cloud. I mean, actually, this is the view here. This is the AWS server, and then this is our cloud-based dashboard that we can provide for them, similar to the VP service that Amino spoke about previously on their cloud service. Except ours, since we're bringing data in from chilled water systems, compressed air systems, and a bunch of electrical metering electrical circuits, it kind of flows up. And now, as a corporate manager, you can look down from the system and see exactly what's happening across all your facilities. And then at the site level, if you're a plant engineer, maintenance manager, you can then see what's happening within your infrastructure systems on a minute-by-minute interval for all your infrastructure systems. The metering historian and control system are able to integrate data from basically Modbus, BACnet, LAN, or any other open protocol. It provides significant flexibility and integration, types of meters, and then, of course, the utilities that we meter through. So now, how does all this translate back to value to the customer at the end of the day? Now, bringing back to the use case at Lavazza, so these are several projects that were driven, either through the use of data or through the use of integration. So the relative large capacity and complexity of Lavazza's compressed air system provides it's a really high value opportunity. There aren't a lot of customers out there with this kind of nitrogen capacity or compressed air capacity, right? I mean, it just is. It's a high margin product that allows the facility to invest appropriately in these kinds of systems, to either dashboard or to adhere to an ISO standard, and to continue to get better. They focus on efficiency. They want to continuously get better. So through the use of the system, they do flow-based sequencing and then stage for down days and production days. And through it, we're basically able to obtain an incentive for them for the smart sequencer, available incentives that pay for about 30% of the upgrade cost for the project. The project, by the time we were done, between cooling and piping changes and everything else, was about $300,000 or so, $250,000. The incentive that we received back with the smart sequencer, with metering, everything included, was $90,000 from their local utility. Of course, the automatic bulk feed is something that we employ on a majority of our controls projects. That includes nitrogen generation. We recommend that our customers maintain their current contract with the bulk gas supplier while implementing self-generation. The bulk tank rental costs are very minimal, while the reliability assurance it provides can be substantial. At Lavazza, the bulk tank serves as a capacity management tool, as well as a power curtailment opportunity. The facility participates in demand response, which I'm sure it also exists in Europe as well, where they are asked to shut down certain systems to relieve stress on the electrical grid. And then during these events, the facility is able to shut down its air compressors that make nitrogen and then operate on bulk. And then it sheds about 500-600 kW of electrical load from the grid, and then the facility then gets incentivized for participating in the program. Through the metering system, the facility is also able to continuously justify upgrade of its older compressors while still leveraging available incentives. So because we have metering at the site, we know the opportunity that exists for either better sequencing or upgrades to hardware or leak load. And every time there is a specific project that's done, we can then circle back and apply for more incentives to help offset the cost of those investments to keep the space or to keep the entire facility updated and going forward. So in summary, the Lavazza utilizes the metering data as an MAV tool for utility incentives, which we help submit for them. And capacity awareness, so they know about capacity constraints when they are looking to add new equipment, or variability within shift production or SKU production. The capacity awareness is a big deal, and the system sequencing of the compressors is also a significant value to them. So because the way that we approached this was from a tiering structure, and so looking at this at the top level, the top two, tier 1 and tier 2, from the site and system level, the power curtailment, basically moving them from bulk, from generated to bulk nitrogen shuts down the nitrogen air compressors, and this basically allows them to make, in terms of income, maybe another $20,000–$30,000 a year, on that transaction or that process. So it also provides the capital planning, maintenance planning, and cost management for year-over-year understanding of where they currently are on volume, if they're going to add a new production line, where they're going to fall, do they need to add more generators, which they're considering at this point in time, or when they buy a new piece of equipment, what are those requirements and what's the impact on the overall system? So at the production level end, which is the bottom tier, if I may, tier 5, they utilize the data for downtime tracking. So if because we're storing the data on a minute-by-minute interval, we can see when the machine is going to start, stops, purges, and we can then export that data out of the system, and then they can then use their analytics tools to determine shift differentials between operators, between shifts, between SKUs, and then using that data to drive a lot of internal decision making. They compare efficiencies across of course, the production lines once again, and the people and everything else. And that helps to eliminate deviations in processes. Somebody sets a setting on a piece of machine that says that they need more air or less air or more nitrogen. And how does that differentiate across the board? Without line level metering, there really is no way for them to understand what's happening within their individual production lines or based on SKUs. So one of the biggest or greatest values, I guess, for the facility here is within the past 6 years. So when the facility first received its LEED Gold certification, it received $150,000 in utility incentives. And then, of course, within the last 2 upgrades of its compressed air system, the sequencer and whatnot, it brought in another $175,000 incentives. And then through the automatic bulk feed system, they're able to reduce their bulk nitrogen costs by roughly $250,000 a year, while ensuring reliability of a reliable supply of nitrogen to the site. And they continue to use the system for capital and operational planning as it continues to grow and further automate their processes. I think the one item that it's hard to put a price on is the culture shaping benefits of a well-implemented metering system. Because the data drives conversations. Like, how many times have we been in a conversation with a customer during the sales cycle, and it ends with questions like, what is your capacity and how has it changed within the last week, month, year? What is your average and peak demand? What is your leak load? What is your primary points of demand? What is the demand from a specific process that we should plan for? And how often do your compressors cycle on and off? And all of these questions can be answered with metering and proper integration, of the data. So it's it's kind of rounding things out. I think during any sales process, it is rarely about the what, like what in terms of equipment that are to be provided, because I think the customers rely on us to determine that for them. If the customer asks for what and they call you, I need a meter for this, then a relationship is extremely transactional, as they have a specific need and we're just here to provide that piece of equipment. The true value rests within understanding of why the customer needs that meter. So I believe that metering is not just the hardware, it's more about the data and the conclusions that can be drawn from the metering data we provide to our customers. So once the system is installed, I recommend just continued dialogue, deep dives with the customer to pull out the true value from an energy management system, so that they continue to reap the rewards of their investments within the relationship and also within the equipment. So in summary, so we should just pursuing the why as once it is asked successfully, it becomes embedded within future conversations. Once the customer arrives at and understands why they're doing metering, why they would like this data, that all the future conversations and all future investments will kind of all wrap around that why, about fulfilling the need for either information to better their processes or for just in general process management. And investing in the greatest scale of impact. Largest users, either electrical or compressed air is the best place to put them, where something can be changed through the data, or if the data helps to show something that might not be fully apparent. When a customer wants to put a meter at a location, but that point, that metering point is a continuous use, there's no significant change, and there's really nothing they can do with that data afterwards, I usually recommend against it. I always like to recommend installing meters at points that has high variability, and it's going to make something really apparent where they're going to be able to make an important decision that makes their process better. And also identifying a site lead who will own and manage the system. So we've done projects where we finish a project and we're not quite sure who will get the training, like who's going to own this, who's going to manage it afterwards. The success of the system relies heavily on having a site lead who has to know how to access the data and then to draw conclusions by converting the data to action. I think that's a really important point from everybody, from the relationship, because the value of the system has to be apparent and it has to be continuously realized on all people's parts. So metering projects can be a challenge in the sales process. If a customer is looking for an ROI of 3 to 5 years, it's difficult to draw a direct conclusion. It's not like a LED lighting project, or if you're moving from a poorly loaded, load-unload compressor to a VFD, you get the data, pre-data, you get the post-data, or you get the pre-data, you run some calcs, and then you get kind of estimate out the savings, so you can determine what the ROI is. With metering, it's a little bit different. So it's difficult to draw that conclusion, such as, hey, you're going to save 3% of your utility or 5% of your overall utility. I think this is why proper cost management is crucial for selecting the right metering products. And I think the best approach is to pair a metering project with support labor post-installation to help the customer transition. Typically, when an initial sale of a metering solution to a customer, they might not be coming from a perspective of where they are used to using information, or they know a lot about the data and what it's telling them. So I highly recommend that some degree of support labor post-installation, maybe 40 hours, to help the customer transition to a data-driven conversations that will help them realize the value of your partnership with them. And then lastly, the data has to be easy access through dashboards, and it has to show a strong alignment with answering the why the meter was installed, so that value is fully realized by the customer when the project's all done. So that more or less kind of summarizes our take on metering at Lavazza in general, and how it can help shape a relationship and create a stronger relationship with your customers by providing them with the critical information that they need to run their facilities. Okay. And if there are any questions, please, I'm not sure if anyone can mute or unmute, or if there are any questions that you'd like to enter into the question box.
Thank you so much, Kai, for your great presentation. So yes, indeed, please leave your questions in the Q&A section.
What are the features focus on when comparing between different metering solutions and products? So I think it depends. There's everything on the product I've seen now is from a compressed air metering standpoint is standard Modbus and 4 to 20 milliamp or pulse outputs. So compressed air meters are a little bit more challenging than electrical meters, because compressed air meter is, no matter how big the header is, it might be a 1 inch, might be a 6 inch, might be a 12 inch, right? It's you're still having to put 1 meter in at a time.